In this section of tutorial, I am going to discuss about characters. In order to represent a character in primary memory, we need to declare variables of type char. Say I am declaring a variable of type char named ch. I want to initialize it with capital A, so the typical statement is going to be equals to single quote capital A single quote. In order to represent a character constant, always we need to enclose it in single quotes. So now the character variable ch is holding capital A. Let me just print the content of ch into the console so that it is printing capital A. Character is %c and I am printing ch here. Format specifier for character type is %c that I have used here in order to print the content of ch. So the content of ch is going to be printed at this point. Let me execute. So here it is. I want to take input from keyboard. So we can use scanf for that purpose. So printf enter a character. Scanf, I'm declaring another character variable here. Character another. %c is the format specifier, then the address of the variable where we would like to keep it. So I am giving the address of another. Now I'm printing the content of another. You have typed %c another. Let me execute this. Okay, it is asking me to enter a character, input a character. I'm giving say q, and you can see that it really has taken q into the variable another. Okay, there is another function by which we can input a variable instead of this scanf. There is a function getChar that we can use for taking character from keyboard. So the syntax for getChar is this. You need to call the getChar function. getChar is going to take the value from the keyboard, the character from the keyboard. It's going to return the character and it's going to assign here in another variable. So you do not need to mention the format specifier for this time if you are using getChar. I'm executing it once more. So here it is asking for a character and it is standing here at getChar. Say I'm giving w right now, small w. So you can see that it is taken by getChar and assigned to another variable here. Okay, so that's how we can input, we can initialize, and we can display characters. Basically, characters are represented as integers in primary memory. Each and every character has a predefined, fixed, and standard value, typically called ASCII value. ASCII is the acronym for American Standard Code for Information Interchange, and this American National Standard Institute, or ANSI, worked on standardization of characters from early 70s, and they produced the first chart containing the standard values for the character sets. That chart was typically called the ASCII chart. So according to ASCII chart, the value for capital A is 65 and that of capital B is 66 and C is 67 and so on. The small letter a is actually assigned a value 97. So if I go on printing the character variable ch assigned with capital A using format specifier %d, then it's going to print the ASCII value instead of the character itself. So if I just go on printing ch using this %d, then instead of the character representation A, it's going to print the integer representation, the ASCII value for A. So I'm just printing both. So here for the first format specifier, where I have mentioned the format specifier for integer %d, the content of ch is going to be printed as integer. That means it's going to be the ASCII value, and here it's going to be the character itself. So let me just execute and show you that capital A is indeed having ASCII value 65. So here you can see that 65 minus A. Now if I declare an integer variable, say I, and if I initialize with 65, and then if I print it using %d, it's going to be printed 65. But if I print the same I using %c, is going to print the capital letter A instead of 65, because %c is the format specifier for character. So the integer variable can be represented as character as well. So here for the first %d, the value of I is going to be printed in integer format, and for the second %c is going to be printed as character. So again it's going to print 65 minus A. So you can see that this second 65 minus A is coming from the values of I. I just need to print a new line here so that the next line is created. Now if I run this in a for loop, say for I equals to 65, I less than 92. Now this printf is going to print all the characters, all the uppercase characters in English alphabet starting from A to Z. Here we go. You can see that it's all the uppercase letter. It's from 65 to this 91. I'm sorry, up to 90 it's Z actually. 65 is A, so 90 is Z. And 91 is actually square bracket, the opening square bracket. So it's printed because I have written this up to 91, less than 92. So let me just make it less than 91. Here is another interesting fact about characters. The uppercase A is having ASCII value 65. The uppercase B is having ASCII value 66, and so on. The lowercase a is having ASCII value 97, and lowercase b is 98, and so on. Now you can see that the difference between the ASCII values of uppercase letter and its corresponding lowercase letter is always 32. The difference between capital A and small a is 32. The difference between capital B and small b is 32. And so it is for C, D, E, F, all the other characters. Now if we want to convert a uppercase letter to its corresponding lowercase letter, then adding 32 is the solution. If we have a variable that's containing capital A and we want to convert it to small letter a, then we just can add 32 to do that. Similarly, if I want to convert small or lowercase p to corresponding uppercase p, I will just subtract 32 from the lowercase letter to get the corresponding uppercase letter. So here's a program that actually deals with this particular property. I have taken a character value from keyboard in variable ch here with the scanf. Then I'm checking whether it is the uppercase letter or the lowercase letter. If it is uppercase letter, that means if this if is true, then it is uppercase letter. That means if the character variable is indeed greater than equals to capital A and less than equals to capital Z, then the ASCII value of the character variable gets compared with the character constant A and Z. And if it is uppercase letter, then 32 is added to convert it to corresponding lowercase letter. Otherwise, if it is lowercase letter, then what we are doing, we are just subtracting 32 from that variable in order to get the corresponding uppercase letter and printing it here. And if neither of these two are true, that means the character is not alphabetic, so we are printing an error message here. So let's execute this program to see that how it works. So I'm giving A and we can see that it's capital A. I'm running once more. I'm giving say Q, that's lowercase q, so it's going to print uppercase Q. Here it is printing uppercase Q. Again I'm running. So I'm giving some non-alphabetic characters, say 4, so it's saying that it's not alphabetic.